Everyone says you can self-host AI on a computer under your desk, and technically you can, but the moment your team or customers depend on it, you don't have a side project anymore. You have a business infrastructure, and that does change everything. We had customers tell us they don't want their data going through someone else's servers. No third-party models touching their intellectual property, but they still wanted to leverage AI. So we built a private AI service from scratch. The gateway, the security boundaries, the privacy controls, the model routing, the infrastructure as a code, and what it all costs. Today, I'm going to walk through every layer of this system and what decisions were made and how you can use AI to help you plan and build a similar system for your organization. Let's jump in. So how did this project start? One is we had some customers talk about, okay, well, we don't want to be talking to hosted models and potentially giving away our IP. And so the goal for us is to silo that into a container that we own and control, and there's no third party involved in accessing that customer data. Now, this is something that is often a requirement in the enterprise world. They want a fully siloed, self-contained, controlled, and they own the software stack, the LLM as well, and they control where the data flows. And this is a common situation. So the way I started this project was I started with a product requirements document. I actually spent quite a lot of time figuring out what is my requirements, what services do I want to use. That's one of the biggest parts of being a software engineer, is designing the system architecture behind it and weighing up the pros and cons of each. There's so many great managed service providers out there now that offer models that are either self-hosted or cheaper rate or scale to zero, like a serverless function, meaning when you're not using it, it doesn't cost anything. There's so many different models now as well. We just have so many things available. But I was thinking, what's the long-term solution that gives us a defensible stack in our startup that we can show potential investors, show potential customers, and understand the privacy and security elements and all of its boundaries to host and control our own models and return our own completions. So in my mind, what that looked like initially was we want something that's like an open API compliant or similar API product shape, and we pass in the model and it returns the completion as we want. But it sounds simple, doesn't it? And you can do it simply with a computer under your desk. And I'll go through some of the self-hosting options there. So this is more of a class on how you would go about structuring the self-hosted model that you can use. This is self-hosted model for a business. You can use cloud providers like Google Cloud Computing, you can use AWS, you can use Azure, and then there's probably plenty of other managed services. You can host models on things like banana.dev, RunPod, just to name a few. There's a lot of options there to host models on, but we want to own that stack. We don't want to send data through other people's servers. We want to own the servers. And some people say, sure, if you're putting it on AWS, you're still sending it to them, sure, but it's in a private network that we control and own, and we have boundaries around that. So it's not quite as good as having your own on-prem service, but we're not investing in all of the infrastructure for redundancy and all of that kind of stuff. So I'll go through that. So the PRD basically defined what we're building, why we need it, and the rules it must follow. The goal was to give our web app its own private AI API, essentially, and then it will send a small request, and the AI model would return a short summary. The important part is that our web app would not be tied directly to, say, OpenAI, Amazon, Anthropic, or any particular model. Instead, the app will ask for like a model that is good at doing a certain thing. We can map it however we want. We can We can ask for specific model overrides. Maybe we fine tune a model and host it in this environment eventually too. So behind the scenes, we can change real model answers and requests without actually changing our web app, but the API shape stays the same. So basically, we turned the PRD into architecture design, a data flow and privacy design. And in this case, we decided to go with AWS and an AWS account design. And that's also equally important to how you structure this to meet certain compliance like ISO and SOC 2 and stuff like that. We also define the security threat model, deployment and recovery instructions, Kanban board and backlog queued, in progress, review done in this repo for GitHub issues. We also then laid out and broke it all down into GitHub issues, branches, and then that then plans out the branches and the commits and pull requests, which basically maps it all out end to end. This is the extent of planning that we do in the engineering world to get it done. And you know what though, don't let this dismay you. This was still all done in one day. Okay. But that said, the state of the project is that it's not fully complete. It's just coded it all up. All I need to do now, which I'll do later today, probably won't record though, is set up the AWS account structure and everything it needs to run the deployment. So the first major decision that we made was to start with a proof of concept using Amazon Bedrock. So Amazon Bedrock, before I go into that, it will essentially it will use the same platform, and we can pivot from using Amazon Bedrock once we've experimented with some models in our proof of concept sort of beta usage. We can pivot that and spin up our own dedicated EC2 models with GPUs attached. But there's a higher cost involved. So we want to be sure that Bedrock scales to 0. So you pay for consumption, and you can choose common models that they have hosted there. There's a lot of different models that they have hosted there. And in some cases, you can choose the location and jurisdiction that model runs in, which is also useful for enterprise, because enterprise typically want things hosted in the country that they operate in. Then we can pivot to our own dedicated EC2 instance. But obviously a GPU instance costs money. So we want to be sure that this will work. That's why it's called a proof of concept, before we pivot to an always-on GPU instance, which is going to cost a fixed amount per month. So what does self-hosted mean? I mean, usually there's kind of different levels of self-hosting or hosting in general. So you've got something like the external API or external AI API. That's just like every other company at the moment. It's like another AI company, our prompts, and we control our prompts and application code. But this is, OpenAI, the Anthropic, and a lot of those services, OpenRouter and stuff like that. So Amazon Bedrock is kind of like AWS operates the models and servers, and that you can control some of the region, the permissions, the retention rules, the model choice, and our API. So we have a little bit more control than an external AI API. Then we move to the next stage, which is using the ECS and EC2, which I'll go through some of these definitions soon in the AWS environment. But these are particular computing resources with GPUs attached to them. And we can operate the model server on a sort of a rented AWS machine. But we still control the model weights, so we can fine tune our own model, serving the software directly, the private networking, and the scaling API. So that gives us even more control. And then we stick down to the on-premises GPUs. So on-premises GPUs is that if you're fully into privacy and you have an enterprise company, this is where this is the golden egg. But this is the golden egg. It's a double-edged sword. So that means essentially we operate the software and we own the machines and we own the entire stack, right? But that entire stack goes out of date. That entire stack needs software updates. That entire stack needs a lot of things that AWS handles for you. And you then are now taking that in-house. So you need the IT team with the skills and capabilities to build a redundancy platform. But you might say, okay, well, yeah, but I can put some Mac Studios in a stack in a server room, and you can do it that way, sure. And that is, I mean, it's still going to be tens of thousands of dollars with Mac Studios with enough VRAM in them to run really good models, particularly if you have a coding team using it, or you've got models that are doing like support requests and on live websites, stuff like that. I'm not talking about the consumer user here. You know, I host my own LLMs at home on my Mac Mini and my other Linux machine. But that's just for me to use. Like, I'm not using it for commercial coding at the moment. I want to get to that point. That would be great. But at the moment, I'm using it for just having private conversations, maybe giving my wife access to it. It's you know, but if the network goes down, or which is, you know, it's flaky where I am, and that's the other thing. Houses typically have flaky things, whereas flaky internet, whereas these data centers, of course, have solid trunks going straight from like core nodes, which can handle much higher throughput and stability. And plus they have redundancy. So if our EC2 instant, one of the GPUs on the instance dies, or the CPU machine dies, you can have almost a seamless transition to another machine. So this is why enterprise look at this a lot different. So for us, Bedrock is kind of the middle ground. It's not always correct to say. It's not correct to say that every AI cloud provider automatically trains its models using customer data. The enterprise concern is much broader than just training on data. Is the data stored somewhere? Is it shared with the model maker? Can it be used for training? That's one aspect of it. What region is it processed in? Who can access it? What evidence sort of proves that the rules have been followed? So, like, an audit trail is super important in this, and when you get into the enterprise space. So our Bedrock project at the moment is to use like a data retention model of none. Obviously there'll be context windows and stuff like that. That's sort of in memory that's happening, but we're not storing those conversations directly at the moment. We might change that model in the future, but it would be stored in the local region in that we control, no third party would access it, stuff like that. So if we were to go down that route, basically, so AWS says in this mode, there is a data retention model mode you can choose. You can requests and answers are not written in a durable storage anywhere. Requests and answers are not shared with a model provider, and models that cannot support zero retention are blocked. So you just can't choose them. And there are certain models like that. So that's what you've just got to be careful of in this world. So it solves a large part of the privacy problem in that, and then the IP of our customers stay within our environment and is returned. You know, we're providing useful outputs to them to better their business. That's kind of on it, and then they still own their inputs. You know, that's their commercial IP. So yes, AWS infrastructure still requests. You know, the requests are processed in memory, but Bedrock is private managed inference and it's got very strong controls. It's not a model server that we operate ourselves, so we don't have to pay that upfront cost and then the ongoing cost of an IT team to keep it patched and up to date and secure. But ECS and EC2, when we pivot to that, will give us control over the model weights and the serving software. AWS still own the physical cloud machine, so that's important to always understand. And on-premises deployment, if we were to one day go down that route, it's required to remove that cloud provider from the infrastructure boundary completely. So let's have a look at our infrastructure. So this is the sort of a simplified version of our infrastructure. So we have our user, we have our web app, We have our web app. It could be on Vercel or Railway or wherever you like to host your web app. And then say we asking it to create a summary of some data points. So we send the data to, in this case, the AWS block. And just ignore this block. I'll explain that in a second. So we might say we want a summary of that data. We might have a deterministic way to create a summary based on, like, it's not using AI, using some rules that we might know. It might be industry specific or expertise that we have built into the logic, in the business logic. Or we could send it off to our new API gateway that we've built, and it's guarded by what's called front door. And then that basically is our API endpoint that it triggers a Amazon Lambda function, which fires up. It's a serverless function. It fires up, checks and routes the request for us, and it's going to make some logs. So we have a bit of an audit trail. And then down here, we're going to choose, what model is it getting routed to? And at the moment, we're going to have, Amazon Bedrock is going to do the inference and return the payload. And then in the future, though, we could choose a different model or our hosted version of that model to go to our fully future self-hosted model. It's still in the AWS environment, but it would hit our EC2 instance with the GPU attached, and would use something like VLLM or NVIDIA NIM to load and serve the model. And it will pull the model weights from like an S3 bucket or something like that. These are approved weights that we might have fine-tuned, for example. And then it will transfer that data back and give us the summary to show to the customer. So basically what we're building here is this boundary, the API, and using the managed service Amazon Bedrock. And then eventually we can easily expand it to build here. Now this box up in the top left corner here is how are we building all of these services? What do I mean by building? I'm not going into Amazon AWS console and clicking add a Bedrock, add a Lambda, add a gateway. Oh yeah, I also want CloudWatch. You can do that. Like, they've got self-managed, but it's quite complicated. I mean, the way I'm doing it is complicated too, but you only have to do it once, and it can maintain the state. So I'm actually using infrastructure as a code to manage all of this. So infrastructure as a code is basically where you write code in your GitHub repo or whatever repository you use, and it can provision the framework for you. This framework will be like, okay, can you create the API gateway and provision it with these specific endpoints? Can you provision the Lambda function with these routing options? Can you provision CloudWatch so that we have somewhere to have our logs? Can you provision the Bedrock instance and fire it up? So that gives us, and then eventually it'll be like, can you provision the ECS, the EC2, the GPU, and VLLM, and the S3 bucket where the model weights sit. So there's a lot of configuration. It's very configurable. It's a lot of code, but it means that when you run it, it creates a plan of the infrastructure it will be built. Obviously, you need to authenticate that plan so it can run in your accounts. And then once you're happy with it, you can hit apply, and it will literally provision all of those resources, typically through, in this case, the AWS CLI. But I'm using a library that's built on top of that called OpenTofu, which is kind of a fork of Terraform, which is a great infrastructure as a code platform. So yeah, that is kind of what we're aiming for here. We will use GitHub Actions once we've set up the initial stack, GitHub Actions to do some of the provisioning as well. But if you had another pipeline runner, you could use that as well. So what does OpenAI compatible mean? Our API will look similar to OpenAPI, but it does not call OpenAI. It supports like familiar routes, for example. Like, it will have the V1 models, V1 chat completions, might have an internal V1 endpoint for a specific routing. And then we might have like a health endpoint as well. So it just basically means it speaks a common language to the existing AI tools that a lot of these models and programming models understand. And then we can output open API compliant documentation, which models will just understand very easily. Our application can point to an OpenAI compatible client on our own URL, and it can request the logical model, like it might be a specific model we create for creating that summary, for example. That's fine-tuned for that. And then Amazon Bedrock also does provide OpenAI compatible regional endpoints through it's called the Mantle interface system, including an endpoint in Sydney. So that solves our jurisdiction sort of issue with Bedrock. But then, of course, when we move to the EC2 system, we can just host that in Sydney as well. So these are, if you want this list of all of the definitions, you're welcome to let me know and in the comments, and I'll send it to you. But basically, these are all the services that we're using in our stack. We've got the product requirements documents. We've got the work OS we're using as the main enterprise authentication process. We'll use Vercel as the web app and API. We've got the web app's already built, so we're not building that. AWS organizations is what we use basically under one company umbrella. So we can have several accounts under one company umbrella, which is important for security and privacy. Is you set up a billing account, and then you set up sub accounts under that, maybe for development, staging. You might have a sandbox area as well. So there's a lot of options there. So we use a tool called Control Tower, where it basically watches over your AWS account infrastructure. The IAM Identity Center, which will be used to give named people temporary access to certain services just for admin purposes. Same with the IAM, will be the AWS permission system, like policies, and we can set specific boundaries that services can touch. Well, OIDC is something that you use in GitHub and Vercel, so they can access AWS without having to store like keys from a security standpoint. API Gateway, so that is basically the front door of our AWS API, which is a Lambda function. So AWS, and that just handles a lot of the common sort of throttling. You can have stuff like dedicated API keys, key management, stuff like that, all handled in there. Lambda, that's basically the code that rakes up, hosts our API, and then goes back to sleep afterwards. We have an open API compatible API, which will sit in Lambda, basically. We can write that in whatever we want. It could be JavaScript or Python. For example, we might have a summary v1, which is a nickname model pointing to a selected model. It could be, we could call, well, I think Bedrock has a lot of its own models, but once we create our own model, we can call it there. Yeah, Bedrock, obviously know what that is. It's the AWS service that runs AI models on managed machines. We have Bedrock Mantle, which is OpenAI compatible model serving system. Zero data retention, so that's super important. CloudWatch, that's where we'll be doing all of the logging and monitoring. OpenTofu, that's where we create the cloud infrastructure. S3 is where we store files and folders and weights. KMS is AWS encrypted key service, which OIDC uses and services can use to access each other in a secure way. Yes, AWS it's like the simple container manager. So you basically put Docker containers in there, and it can fire up your provisioned EC2 instances there as well. And then the EC2 is the rented computer with the GPU versions. So we define that specific instance and fire it up. We've got VLLM, is open source software that serves language models efficiently. NVIDIA NIM, it's essentially the same sort of thing. ECR, it's just a storage place to store your Docker containers, which are the images for your EC2 instances. Private link, it's a private AWS network path. Kubernetes, although we're not using that at the moment, but eventually we could scale into that. It's basically a general manager for many containers and many machines as you scale. And then EKS, which you'd use, it's AWS managed Kubernetes service. That is basically when we have a lot of, like, thousands of users using this. So we're not going down that route at the moment, because there are some pretty hefty costs involved. So you need to make sure you have that return on investment. So how we organize the work. So this is kind of an important aspect when I try to orchestrate anything, really any project. Essentially, I'll zoom in a bit. So we start on the PRD, and then we agree on the goals and rules. So I found with the new ChatGPT 5.6 model, high thinking in the Sol variant, it's really good at understanding these more detailed builds. So we can define the architecture and privacy issues and Kanban boards. We did AWS account plan. We drew out the map. We did OpenAI style API contract definitions. So that was kind of the first wave of work that we completed. And then that was all done in parallel. Then wave 2, and you got to think about this in terms of concurrency as well. So how can you parallelize some of these build contracts so we can get it done faster? Otherwise, if you do it all sequentially, you could have 30, 40 pull requests that you just have to build sequentially, and that could take days, literal days, to get that done. But the slowness isn't the model. The slowness is the review cycle. So it's better to sort of cluster review cycles. You could do it after each wave. You could do it at the end. There's a few different approaches you could do it. It also comes down to the commit plan. So how are your pull requests getting committed? Are they in a stack? Are they independent features? How are you actually going to merge them in a sane way? Because it's a lot of code coming in a few different waves, and so it's important that you have ability to check things as you go. So yeah, wave 2, that's when we built out the OpenTofu Terraform style plan and files, and that includes like how we managing its state. So OpenTofu needs to know what's the current state of the entire infrastructure, and if that state gets out of sync with the plan, that's how the plan consolidates what resources to add or remove. So that it's a state management is really important with that. So we also built out the provisioning of the gateway and the Bedrock adapter. Not the provisioning, sorry, it was the code itself. The main web app connection, like how is the existing web app going to talk to the new provisioned gateway and consequently the downstream services. Synthetic tests and privacy checks. So we did a lot of testing to make sure that things like type checking, the CI checks, stuff like that, to ensure that the code is still secure and safe and that it functions as intended in terms of business logic. Then wave 3, it was like, okay, let's bring them all back together. Let's bring it all together. And this is basically where you've reviewed wave 1 and wave 2 pull requests. You're bringing them back together, and you start merging the pull requests in the order that they need to be ordered. And then you run the OpenTofu checks, and then finish the human deployment. So that's what I physically have to do inside AWS to set this platform up. So wave 4 is mostly fine tuning, create AWS landing zone. So we've got the account structure set up. We create encrypted states and roles. We've done the plan already, but then we'll actually do the first apply stage. And then there might be a second apply stage as well, which creates the first apply stage would be setting up like the privacy and retention models inside the AWS ecosystem. And then the second stage is the gateway and model candidates are getting deployed so we can start using it. And then finally, we get to the prove it works, the run smoke, privacy checks, compare models, and then, point at the best model for our use case if we're just using the Bedrock models. And then there's the future enterprise path from there to add private networking, fire up ECS and EC2 to build our always on instance, and choose a model there. Or maybe at this point we've been able to take maybe an open source model from Bedrock and fine tune it, that we could do offline, and then we upload the model weights for that model into our S3 bucket, which is connected to the EC2 instance. And then we could do, at that point is when we would do like a small feature flag rollout to a select batch of customers who have opted into testing some of our beta features. So yeah, you can kind of see how the whole picture takes shape here. So that is how that works. So we'll have a little bit of a chat about the AWS account design for this. So basically the way you set it up to be, you could just set up it all in one account, but that's quite risky for a few reasons. If someone gets access to the admin credentials, if someone misuses one part of this, other services might get affected, and it's difficult to have that kind of audit trail. So typically what we would have is one organization, and then you'd have a managed and billing account. You might even have, this is the ideal setup. It doesn't have to be like this, but you might have a log account as protected audit records. You might have an audit account with just security tools and findings. Then you might have an AI non-production development account for synthetic testing. And then you finally have like the AI production account with future customer traffic. So that's typically how like a backend engineer would design an account system like this, or a DevOps system person. Then this is actually the stuff that was built. So these are all the pull requests in GitHub. So yeah, so that is, probably won't run through all of those because there's a lot, and I've still got to review them all and merge them today. So how much does it cost to build all of this? Of course, there's my time. I'm employed to build stuff like this, and I live in this world all day long. So it's a little bit different for me. But there are different costs to build this. I mean, usually if you were to hire an organization or a developer to do this for you, it could cost hundreds of thousands of dollars. So I'll go through some of that. So there's a different cost here. There's building the actual software there. There's running the managed Bedrock versions of models. And there's also the cost of operating our own GPU machines. So in traditional engineering costs, you've got stuff like a normal person, a professional estimate for this scope would be like approximately 250 to 500 engineering hours if you were to code it all and build it all without AI. Another 20 to 60 hours for security and privacy deployment review. Another 5 to 10 weeks of one experience, around 5 to 10 weeks of one experienced engineer, or around 3 to 6 weeks of a small team working in parallel. At professional rates, you'd be looking at 150 to 250 per hour. Like this represents probably around 40,000 to 140,000 USD to build something like this. A formal enterprise version with proper penetration tests and compliance evidence, like SOC 2 compliance and ISO standards and stuff like Essential 8. We've got production networking, incident exercises, and even multiple environments that we're testing. Like that, you'd be looking at building. It'd be way more than 140,000. So an AI assistant development can help reduce the coding time specifically. but it does not remove the need for human security review, AWS account ownership setup, privacy decisions, model license review, deployment testing, and production approval. But you can see that most of the hours is still spent in the engineering hours. So some of those would be manual hours, of course, but a lot of it would be the code side. So in this day and age, we do save a large chunk of it, but there's still a lot of review steps. If you were going for like SOC 2 compliance, a lot of review steps that would need to happen, which have substantial cost as well. So how much does the Bedrock POC cost though? So a sensible planning allowance for low volume proof of concept. I mean, it's just basically the engineering team testing. It's not many users. Like it's only going to cost about $50 to $200 per month. So it's not a lot when you're just doing a proof of concept. This excludes, like other hosting costs like we're using for our database and application. And any human cost to this. The allowance includes like AWS account logging, S3 storage, KMS encryption keys, Lambda, API gateway, CloudWatch, basic security, and the low volume inference with the Bedrock models. So Control Tower itself doesn't have a cost. However, there are some costs for other paid services. But it's still a pretty low cost overall stack when you're just doing the proof of concept. Like some examples, it's just like Open Router where you pay per inference. It'd be 15 cents for 1 million input tokens, 61 cents for 1 million output tokens for the Qwen 32 billion parameter model. So I won't go through that. So what about the GPU cost? That's probably where this is what we want to scale into, and this is where it can be quite expensive. So a GPU machine can cost far more than any normal CPU machine. If you were to just launch a CPU instance, you could get a pretty reasonable 32-core PC for a few dollars per hour. Whereas, for this, if we have a development GPU switched off when unused, then it might be a couple $100 a month or something like that. But we might just fire it up either manually or through the CLI to just run some inferences to test it and then turn it off. But once we're ready to go online, we might go one capable GPU server running all month. Depending on the GPU, that could cost from $1,000 to $8,000 per month. And this is, it starts to, if you have 2 or more servers running for reliability, it could cost $3,000 to $20,000 per month. So you just have to be mindful of that this is specifically for that kind of bracket of enterprise. So if you're making multiple hundreds of thousands of dollars per month in your business, then this would be a potential route for you to solve the IP problem, the networking problem, the customers concerned about where their data is going. This is potentially you becoming your own OpenAI and Anthropic without actually fully training the models, though. So that's kind of where big expenses come in. So basically large multi-GPU models, you're looking at potentially tens of thousands per month. And there's a line to draw is like how much do you spend per month before you start investing in, if you want to, into on-prem. But on-prem still, even then, at that level, would be phenomenally expensive to get into. I probably won't need to talk about that. So why operate your own model? So we may move from Bedrock to our own GPU, mainly because we want direct control over our model weights. We want control over the model serving software. We want fewer external services inside the data processing boundary. So we can house and isolate all of that AI work separate from our actual user-facing API. So it's kind of a separate thing. User-facing, web app and API. Maybe we want a model or a purpose-built model that Bedrock doesn't offer. We might want special model settings and performance improvements. We might want to train our own model, which is a whole separate other thing. Maybe customers are the ones who are requiring operational boundary. And we might end up firing up, if our customers are large enterprise customers, we might fire up dedicated GPUs just for them. We might want to move between AWS, even another cloud, on-premise hardware and on-premise hardware eventually. We might want to avoid becoming just dependent on one model provider. You definitely need redundancies built in, which we've learnt because even OpenAI and Anthropic have downtime. But operating a model means we become responsible for all of these things: GPU, CUDA, software, model licenses, security patches, scaling. I mean, we're a dedicated team for this purpose. So it's, you just need to think about, though, this is just a glimpse into the engineering path. And you can see that engineers in this space aren't going to be replaced anytime soon. So if this is something you want to learn to do, it's a good space to be in, because enterprise want ownership. And if you have the skills to build systems like this and test them, roll them out, then it's unlikely, in my opinion, that you'll be completely replaced. Obviously, people, OpenAI, the biggest threat would be OpenAI or Anthropic have those forward planning engineers that do embed with large enterprises to build out the AI system for them. I'm not sure whether they do fully on-prem or not. I'm not sure, but I believe that they're heading in that direction. So that's probably the biggest threat, but that would be at the top echelon of enterprise sort of plans. So yeah, I think that's pretty much all I wanted to go through today. I could probably go for more. So if you wanted to build something out like this yourself, I can just dump this kind of document in the comments if you want, and it kind of gives you the architecture that you need to do it. A bit of a learning step, but you'll learn a lot of the terminology to prompt things like the latest Anthropic models from Claude or OpenAI models, and they are really good at building this infrastructure. And then asking, you can ask them, what manual steps do I need to take to set this up for you and give you access? And they'll guide you through it. It does take time. It's not just like set and forget. And there's a lot of manual steps involved. But I think, long term, this is what a lot of commercial teams really need. And this is essentially a forward planning role where you're going in, you're building them the infrastructure they need, and then essentially you understand the infrastructure, and then you talk to them directly and understand their business logic and how they want to inference, and then you build that on top of this. Essentially, this is the foundation. That they still need the gateway, they still need somewhere to host the model, they still need that back and forth. Then they might talk about fine-tuning a model. They might talk about how that model's delivering. They might be building a custom app themselves. But if you can build this for them, that solves a huge problem around that exchange of IP, that's those security boundaries. So yeah, it's something worth considering. Then there's a whole nother level on top of this though, which if the organization is planning to do SOC 2 compliance, they might have their own security and cybersecurity experts. Then you'd need to work with them closely to test and they might even hire a third-party pen testing team to test your infrastructure and make sure that each component meets compliance. And then there'll just be lots of small tweaks to make. Things like, especially around the API gateway, and the security boundaries you set up in the deployment process. The API gateway, you're obviously with an API, you typically allow certain parameters through, certain body through, that needs proper type checking all the way through, so people can't inject things, stuff like that. That's a whole world in itself, cybersecurity. So a lot of engineers forget about that part, but there's a significant part to play there to ensure you meet SOC 2 compliance. The reason why, sorry buddy, I'm busy, bye. So the reason why I mention that is mostly because people and enterprises are typically moving in this direction with the goal of privacy. And one of the best things for a company to say to a customer is, yes, we're maintaining these compliance standards. And maintaining those compliance standards, it's a selling point, because their customers are probably the ones that informed them that they want to protect their IP. They want to understand the security. They want to make sure that the data use policies and privacy boundaries, because it's important to them. So therefore, it's important to the organization who builds this, and a path to help defend and make that claim defensible is the actual then getting the certification. So that's typically one of the reasons why people go down this route. All right, that's it for now. I'm going to, today, my goal is to do the manual steps of setting up and provisioning the AWS accounts. And I might do a part 2 of this. We'll see how it goes. But yeah, hopefully if you stuck around, I know it was a longer video. Thank you so much. And please subscribe if you want more detailed walkthroughs of real engineering setups in the AI space. Thanks.